When you send a prompt to a model, it produces an array of probabilities over the words that could come next. And from this array, you need some strategy to decide what it should return. A simple strategy might be to select the most likely word at every time step. But this method can result in uninteresting and sometimes repetitive answers. On the contrary, if you randomly sample over the distribution returned by the model, you might get some unlikely responses. By controlling the degree of randomness, you can get more unexpected, and some might say creative, responses. Back to the model parameters. Temperature is a number used to tune the degree of randomness. Low temperature means to narrow the range of possible words to those that have high possibilities and are more typical. In this case, those are flowers and the other words that are located at the beginning of the list. This setting is generally better for tasks like questions and answers and summarization, where you expect a more typical answer with less variability. High temperature means to extend the range of possible words to include those that have low possibility and are more unusual. In this case, those are bugs and other words that are located at the end of the list. This setting is good if you want to generate more creative or unexpected content. In addition to adjusting the temperature, top K lets the model randomly return a word from the top K number of words in terms of possibility. For example, top 2 means you get a random word from the top 2 possible words, including flowers and trees. This approach allows the other high-scoring word a chance of being selected. However, if the probability distribution of the words is highly skewed and you have one word that is very likely and everything else is very unlikely, this approach can result in some strange responses. The difficulty of selecting the best top K value leads to another popular approach that dynamically sets the size of the shortlist of words. Top P allows the model to return a random word from the smallest subset with the sum of the likelihoods that exceeds or equals to P. For instance, P of 0.75 means you sample from a set of words that have a cumulative probability greater than 0.75. In this case, it includes 3 words: flowers, trees, and herbs. This way, the size of the set of words can dynamically increase and decrease according to the probability distribution of the next word on the list.